right, here, integration annihilation. Let's let it begin. Let's start annihilating integrals. Here we go. Wow, you know, doesn't look like U substitution is gonna work on this one. You know, the fraction composition's kind of weird. So I'm just gonna rewrite this one. I'm gonna go 1 plus sine x dx. And then I'm going to concentrate not on the integral, but just what's inside of it. This guy. I'm going to 1 over 1 plus sine x. That's all I'm going to concentrate on. I'm going to look at that, and I'm going to go 1 minus sine x. 1 minus sine x. Right there. Just like that. And that becomes 1 minus sine x over... We're just going to use the FOIL method, and that's going to be, you know, you've got the opposites here, so that's going to be 1 minus sine squared x. Okay, if you think a little hard about it, cosine squared x plus sine squared x equals 1. Old Pythagorean identity. Going to do a little subtraction of sine squared x from both sides. So right here, this is going to cancel out, and that's going to be cosine of x. Cosine squared of x, sorry. So let's go ahead and let's write that down there. 1 minus sine x over cosine squared x. And it looks like I can probably maybe do a U substitution for cosine x if I split this thing up into parts. Not integration by parts, just it's fractional composition. Remember, I'm just gonna split the fraction, minus sine x over cosine squared x. That's perfectly legal. So it looks like I can integrate this thing term by term now. This 1 over cosine squared x, well, you know that. That's just secant squared x. So let's rewrite it. So now we got the integral of secant squared x. We already know the derivative of that. Over cosine squared x dx. So now I got that. Heck, we know that the derivative of tangent is secant squared, so let's just go ahead and write it. Tangent x plus, well, over here, what am I going to do? Let's get another colored pen and do our U substitution. Just like I said, you know, it looks like the derivative of cosine is negative sine. It's sitting right out there. So let's go ahead and do U equals cosine x over here. Du equals negative sine x dx right there. So it looks like we can go ahead and negative sine x dx is equal to du, and we got that right here, so let's just put du over cosine. We use a U substitution for cosine, so let's stick him back in there. That's going to be U squared on the bottom. Okay, so moving on, going to use a little scratch paper, nothing big. Let's see, we'll just rewrite this. Tangent x plus integral of u to the negative 2 du. Okay. And this is going to simplify a little bit further. Let's just use our power rule there. That's just going to end up being u to the negative 1 over negative 1 plus c, which is going to equal tangent x minus u was cosine x up there, so that's cosine x all to the negative 1 plus c. So this is going to end up being 1 over, this is going to end up, because of the negative exponent, it's going to end up being 1 over cosine x. So that's just going to, we're just going to call it secant. Bada bing, bada boom. That's how it's done. That's how I roll, right? Okay, cool. Actually, let's just run through it again. One more time, okay? We started out with this weirdo. We made it look like this weirdo. And then we multiplied by, basically, we just multiplied by 1, if you think about it. We got something that we could work with. We used Pythagorean identity, and the only way you would know how to do this is if someone showed you, or if you were a genius, okay? That's why, you know, you got to read your book, you got to hang out with your buddies at school, you got to talk to the professor, you know, you just got to do that sort of thing. Because integration is not, it's more of an art, actually. So that's what we did. Then we were, you know, we got a little lucky here. We had a direct integral right there. This we only had to do a u sub, so that's not too bad. All right. See you in the next video on and we'll annihilate more integrals. We're gonna destroy them.